So this thing is a number. And in Java, you can't do a number and a dot and a method. That's just something that we're going to have to remember, because with so many other things, that is exactly how you operate. If you looked at the code for the beach chair, actually, you must have written something where it says chair.move in the last lab. I don't remember the exact code. What was it? Does anyone remember how to make the chair move?
Chair.move.
It was chair.move, and then there was by how much. So it's the same thing, that this is the object that we want to do something with. This is what we want to do with it, and then there's some extra parameters. So this whole pattern, object.method.parameters, it's prevalent in Java. You use it for all sorts of things to make things happen. Or when we have a rectangle and you call translate on it. Same thing. Object, method, more details about the method. And it works for everything, except it doesn't work for numbers, for technical reasons. That actually are no longer all that important, but there you go. All right. Now, identifiers. When you name something, gosh, this sure goes on forever. When you name something, here I'm naming this thing greeting, and there's a number of boring rules on what you can and what you can't do to name these things. The most important rule is no spaces. So, like previously, we had something where it said like unit price or average cost or something with a space in it. You can't do that. If you ever feel the need to do something like that with a space, then you have to use what's called camel case, where you write the first word in lowercase and then you put an uppercase letter where otherwise the space would have been. And that way the I can separate that. You'll find that all the time in Java. And it's called camel case because when you look at a word like that, it has like this little hump in the middle that's made by the uppercase letter. So, here. So that's a camel. And it's a silly name, I know. All right. So as long as you just stick to letters and maybe the occasional number and lower and uppercase letters and no spaces, you're fine. I will not have a quiz question that asks you exactly these rules. So just when you'll find out if you. No, I don't think you'll ever run into trouble with this. All right. So here's again the variable declaration that we had before: type, name, initial value. Next, assignment. So over here, I'm starting out with what I had before. The type, name, and value type is integer. Width equals 10. And that makes a variable. Here I'm making a little picture of that variable. And you see that inside it has the number 10 in it. Now, on the next line, I say width equals 20. Notice that the difference between these lines is very subtle. The first one has a type, and the second one doesn't have a type. That's the only difference between them. And that little difference, though, means that they act very differently. When you have the type and the name, that makes a new variable. So this line here makes a new variable. When you just have the type, then that means it uses an existing variable. And the equal, of course, means now we set the existing variable to a different value. So you can think of this thing as a little slot that holds a little some information. It started out holding the number 10. And after the second assignment, it now holds the number 20. So it often happens that you start out something with one value, and then you want to change it over time, and that's when the assignment comes in. And it's just worth noting that the syntax is a little subtle here, that if it starts out with a type declaration of new variable, otherwise it means reassign something into an existing variable. So what a program typically does is it'll stick different values into a variable, maybe in a loop, maybe in a bunch of statements, and then later one looks up and sees, well, what is it now? For example, if we write a program that counts how many people entered into a room, one might just increment the counter every time a new person arrives, and in the end, one looks up what's the value of the counter now. So that's how these variables work. And so this thing is called the assignment operator because it assigns the thing that's on the right to the thing on the left. It is legal to declare a variable without initializing it. Here, so I'm saying it's a declaration. It makes a new variable. You can see that because it starts out with a type. So it makes a new variable called height, but it doesn't put anything in there. That's not something that you should generally do, because at this point, if you were to try to use height, that's an error. There's nothing in it. The compiler will catch that error, so it's, you'll notice it right away. And the obvious remedy is to put something in, just saying int height equals 20 or whatever you wanted to put in there. Yeah, that's the remedy. Now, down here, I said that's an even better thing. So I had an int height here, and here I initialized it. And now I had this width here, and I set it to height. And this width itself must have been declared somewhere up. Somewhere else it must have said int width. And so over here I said the best thing is if you can make it so that you declare the variables just when you need it. So the first time that you actually are ready to put a value in it, that's when you declare it. And that way you always have the pattern that the declaration has an initial value. Initial values are good. This is just not my day. What did I just do? Maybe this right after lunch thing is not working out for me. All right. Now that's all I want to say about variables. Most people don't have too much trouble with it because, like I say, they work just like in mathematics, except for that little thing with the types. But I do want to talk about objects because that's something that's new, and initially it's pretty confusing for people. And I'm going to hit you with objects from like 4 or 5 different views so that hopefully they will all eventually fuse in your brain and you'll get a good intuitive understanding of what an object is. So one way of thinking about an object is the beach chair. The beach chair is the perfect object. It is there, and you can ask it to do certain things. You've done that. You've asked the beach chair to say, "Hello, Steve." And it did. You asked the beach chair to move, and it moved. That's what an object is. It is something that you can ask certain things by sending methods to it, and then it does them. The reason I can't put the beach chair in the book is that I actually tried this, but people say, well, this Alice stuff, it's not serious. It's a toy thing. It's for kids. And to me, that's all wrong. The Alice thing is great because it makes you visualize something. If you can imagine an object, if you can say, I've seen one before, and a real thing, then that gives you a way of thinking about, an object is just something that responds to commands. Now, the one that I am able to put in the book is good old print stream, because that is a serious object. It's something that everyone needs to know about. It's good old system.out. And so, but it's a little bit harder to understand what system.out actually does, because it puts characters onto this terminal. It's not as interesting as moving around or saying hello, but in an abstract way, it's kind of the same thing. When I ask system.out to print something for me, it does some amount of work. That work means it shovels characters to some place on the screen. So the object does some amount of work. So, and the way that it's symbolized here in the book is that this is the name of the class to which the object belongs. I'll come to that in a minute. And then we have the methods that you can execute on the object. In this case, they're print on and print. And so for the beach chair, if I were to draw the same diagram, I would say the name of the class is beach chair. And one of the methods was move. and one of the methods was safe. And these are methods that a beach chair can do. Now, what goes on inside a beach chair? There's a lot of internal data where it knows how to paint itself. Just like the print stream has some internal data where it knows how to send characters somewhere. These are not things that we really understand. We don't have a clue how a beach chair operates. If you ask me what goes on in the inside of PrintStream, I've been using PrintStream for almost 20 years. I have no idea what goes on inside PrintStream, and I will never find out. I have no desire to find out. That's the same thing that I have no desire to find out how my automatic transmission in the car works. Do you know how the torque converter does its thing? You just push the pedal, right? And that's exactly how you use an object. You know what it can do, and you know that there's some gearing inside that does the right thing, and you don't want to know. You honestly do not want to know. So those of you who can drive a car without knowing how the automatic transmission does its thing will understand objects. So with an object, you have things that they can do, and there's a finite number of things that an object can do. Like a beach chair cannot explode. There is no method for explode. Neither can PrintStream. If you try to call system.out.explode, the compiler is going to say system.out has no explode method. And there are other things that they can do, and for every class you need to know. So what's the deal with classes? So in our program we've had a single beach chair, but it's actually a simple matter to populate it with 3 or 4 or 5 different beach chairs, and each of them is its own object. And each of them could say something different. That would be a nice little lab assignment, actually. That way you could visualize that each of them is its own object. But they all are objects of the same family, and that family of objects is called a class. That's just a technical name. Maybe not a very good one. With PrintStream, it's a little bit harder to see because we know system.out, and you will not see another PrintStream for another 6 months. Later on in 46B, you will see more print streams that can print to files, or that could print to a web server. But right now, all you're going to see of that particular class is system.out. So, methods. A method is something that the object can do, and it's just very important that we understand the funky syntax. So let's look at this call here. We have first of all, we have a declaration. We know it's a declaration because it starts out with a type. So it declares a string. The string is called greeting. It's initialized with hello world. Now over here, we're taking that string and we're calling a method on it. And the method's name is length. So this thing is the method. This thing is the object. So if you had a guess, what do you think greeting.length does?
It measures the length of whatever greeting is.
2 inches?
The character,
Yeah. So it counts the number of characters in there, and so how many are there?
13.
Okay, so I hear 13. Do I hear 14? All right, 14 has it then. No, so we have 5 for hello, 6, 7, the space counts, 12, 13. So the quotes don't count because the quotes are not actually a part of the string. They just delimit the string. So this sets n to 13. So the length method is called, returns an answer, that answer is stored in it. N is now 13. Now, if you remember from a previous slide, I said you have an object, you have a method, and then you have parameters. So where are my parameters? They're the parentheses here. And why isn't there anything inside?
The method doesn't need anything?
That's exactly right. That method does not need to know anything else to do its job. So this particular method, as soon as you say, give me the length, then it knows what to do. Other methods are not so fortunate. If you look at Oh yeah, let's use the beach chair. If you were to say chair.say, that wouldn't work. Why not? It doesn't know what to say, right? So you have to tell it what to say as a parameter. And now it knows what to say. So this particular method is a little degenerate in that it doesn't need any parameters. Some methods are like that. Most of them need parameters, some of them don't. Now there is another slight difference is this particular method, greeting.length, returns an answer. It returns an answer that I can use by moving it into a variable, for example. So it's like a calculator button thing. It gives me an answer, something that I can work with. Chair.say foo doesn't give me any particular answer. It does a job, but it doesn't give me an answer. Right. Now over here I've tried to do something. I've tried to apply a method, the length method, onto system.out. And it says this method call is an error. Why is it an error? Not quite. I'm not even asking it to print anything.
Because you haven't specified any length? Or?
It's a little something than that. So system.out is an object. Remember what an object is? It's a blob. It knows how to do some certain number of things. For example, it knows how to do print all. And it knows how to do print. And there's a finite list of things that it knows how to do. Length is not one of them. It simply does not know how to do length. In one object-oriented programming language, if you ask this, it'll actually say, system.out does not know how to do length. In Java, of course, it says something different. It says, you are an idiot for even trying, or whatever it says. So, the point is that some objects know how to do certain kinds of things, some objects know how to do different kinds of things, and when using an object, you just have to know. The collection of everything that you can do with the class is called its public interface. That's what the public can do with it. Okay, I don't want to know this. So what this slide's trying to get at is that you can have two objects of the same class. These are both objects of the string class. The first object contains these characters. Hello, I guess it goes on to hello world. The second one here contains different data. This one is the string that stores Mississippi. And otherwise, these objects are exactly the same. They belong to the same class. They admit the same methods. And they're just exactly the same. So here's the length method, for example, is shared by both of them. They're both strings. The only way that they differ is that they have different contents. That's very common for objects. You usually have lots of objects of a particular class. Like I said before, you can think of a whole bunch of different beach chairs. One of them saying hello Fred, the other one saying hello Jim, and so on. And here we're calling a couple of methods on a string. So here I have the string greeting. I'm asking it how long it is, and as we just figured out, it returns the number of characters, 13. Here I'm having another string, and here now I'm going to call a different method on it. So this thing is the string is called river, and the method that I call is called toUpperCase. toUpperCase gives me an answer, and that answer is a new string where all the characters are in uppercase. That's a very handy method sometimes to have. If you want to write something as a title, then you just call toUpperCase and presto, you're given the thing to uppercase. So there are actually well over 100 methods of the string class. We'll only be using a small handful of them, but it is one of the bigger classes in the library. Yeah, so yeah, I'm again calling system.out.length to show that you can't do that. So how do you compute the length of Mississippi? Yeah?
You say int
That's the value.
Yes. So what he says is you would say, oops, is that am I paraphrasing? So that is absolutely a good way of doing it. We already have the thing in a variable from the previous slide. You just call the length method on it. And then what he says, you want to capture that value in some way. So here he suggests to put it in a variable. And that works great. Another thing you can do is you can just print it out. You could say system.out.println. So here we're computing river.getLength, and we're not saving it in a variable, we're just printing it out so that it appears for the human to see. You would do this situation only if you never needed it again. If it was just for some testing or for like a little student program. You would use this one if you needed the value again for some other computation. Now there's one more thing that you can do, and I'm showing that in this form here. There's actually no need to put the thing into a variable. The variable river, you would only need to do that if you wanted to use it more than once. If you never needed the string Mississippi again, it is an object. It's not a number, it's an object, and therefore you're allowed to put a dot and the method right onto the object itself. So, for what it's worth. I'm going to skip this because I want something else. I need one more thing before we can do the lab, and I'll go over this thing on Tuesday. So we have a bunch of homeworks with these rectangle objects. So I picked the rectangle objects mostly because they exist in the standard library, and one doesn't have to install any special software in there to be able to use them. And they do have one other kind of interesting property. So a rectangle object describes a rectangular shape, a shape like that. But that's not what a rectangle object is. If you look at the internal structure of a rectangle object, it does not have pixels. Instead, it has 4 numbers. And the 4 numbers are the x and y of the top left corner, the width, and the height. So an object ultimately does need to store actual data. And so these are the data that a rectangle stores. And out of that, of course, if you ever wanted to paint the rectangle, you would have all the information that you would need for painting it. Or if you wanted to compute the area of it, you would multiply the width and the height, and that would give you the area. So a rectangle object is a container, so to speak, for these data. Here I have 3 different rectangle objects that actually symbolize what was in the previous slide. And you can see they all belong to the same class. They're all rectangles. But they all have different stuff in them. They are different objects of the same class. Now, with a rectangle, to make them, you have to learn one more thing, and that's what's called the constructor syntax. With a string, it's easy to make one. If you remember what objects we've seen so far. We've seen strings, we've seen print stream, we've seen beach chairs, and now we've seen rectangles. You haven't actually seen how to make a beach chair. That was somewhere in the upper parts, in the incomprehensible part of that Alice program. Oh, by the way, don't try to read it. Bad things happen to people who read that part. So that code is so complicated that it was automatically generated by Alice. And so whenever one operates with this Alice stuff, one automatically generates some base code, and then one just modifies a little piece of it. And that's normal. So you modified the little piece of it, and that was just fine. But the other stuff is fairly incomprehensible. So we have no idea how to make a beach chair. Maybe I'll figure it out one day. We do know how to make a string because you just make quotes, what goes inside, and quotes. We don't know how to make print streams except for system.out, which we get by saying system.out. So those are kind of degenerate things. But with most classes, the way you make an object is by making a constructor call. A constructor call means you use the keyword new, which is pretty self-explanatory. You want a new thing. You then say what class you want a new thing of. I want a new rectangle. And then you give as the parameters something that describes the new thing that you want. So in this case, I want to have a new rectangle with these coordinates. Now what that gives me is that gives me this rectangle. I could then ask that rectangle some piece of information. I could take this thing and now apply some method on it, particularly if we knew what methods one can call on a rectangle. Do you know any method that we can call on a rectangle? Maybe from the first draft of the homework?
Like finding an area of it?
Unfortunately, it doesn't have a get area method. That would be nice. But it just doesn't happen to have one.
And you translate it?
You could call translate on it, yes, and or you could call get width on it. And you can really do that. You can take an object like this. It is an object and hit it with a dot. But it's not very common. The reason is that then it goes away. You no longer have it. And so more commonly what you want to do is you want to store it in a variable. We'll see that in the next slide. Yeah, we don't want to know this. Here. All right, so that's what you almost always want to do. So you make the thing, and that gives you the object, and then you want to save it for posterity, so you have to put it in a variable, and the variable has a name, and it has a type. And of course, it's kind of stupid that you have to mention the type, because it ought to be perfectly obvious that if you just made a new rectangle and you want to put it in a variable, that variable's got to be a rectangle. But that's how Java is. That's how Java is. You have to say everything twice. So whenever you make an object of a class, you have to say name of the class, what you want to call that object, then you make a new one, and then you have to say the name of the class again. That's just the way. And at this point, now we're happy and we can start calling methods on this. And now we're ready for the lab, finally. Sorry, this took a little long. So just get going for the lab. I'll pull it up really quickly. This is lab 1.5.
How this thing does it downs the file.
So with this lab, I'm giving you one of the earlier homework assignments, and I want you and your buddy to kind of walk through what it takes to do this assignment. And then 10 minutes, so you have a good 25 minutes for this, and then we'll talk through how far you got with it. I mean, I broke it down into a million steps. I hope none of these takes too long. And then I want to talk for a few minutes, what does it take to think about a homework assignment?